Hi everyone, a very good morning to all. Now we are going to study about semiconductor. So what is intrinsic and extrinsic semiconductor and what are the types of questions will be asked based on that thing. The very first thing is what is semiconductor? When you consider a semiconductor, see the substance or material you can divide into two types, that is metal, also you call it as conductor, and insulator or dielectric and semiconductor. See, semiconductor means something which behaves medium behavior, like not metal completely, not insulator completely. Metal means which can conduct electricity easily, and insulator means which cannot conduct electricity at all. But semiconductor means it is kind of device you can make something so that it will become like a conductor, a better conductor. So the definition is like metals means more conductivity, insulator means more resistivity, semiconductors means medium. And if you increase the temperature, conductor resistivity will increase, but semiconductor resistivity will decrease. Or that only we will define like when valence band and conduction band both overlap, that is called, that material we call it as conductor. Or when there is a huge gap, huge energy gap greater than 3 electron volt, that is called insulator. And if the gap is less than 3 electron volt, that is called semiconductor. Means here we say that when electron can jump from valence band to conduction band, then we say that there is a conductivity, there is a flow of electricity. And here in case of semiconductor, they have to overcome this energy gap to allow the current flow through it. So when you consider such semiconductors, the very first thing is pure or intrinsic semiconductor. So here we study mainly about silicon and germanium. So when you consider silicon or germanium, there are 4 valence electrons. So that when you consider silicon, it will be like this, or germanium, anything. It will be having 4 valence electrons, so it will share with 4 silicon atoms, so that it will form 4 covalent bonds. So this is the general structure of pure intrinsic semiconductor. So that at absolute zero temperature, all electrons tightly bounded by covalent bonds, strong covalent bonds. Now, as temperature increases, bond breaks and electron becomes free. Then a vacancy created, that is called hole. And hole behaves like a positive charge in case of semiconductor, and electron behaves like a negative charge. So that there is a current due to hole as well as electron. That's why the total current will become IE plus IH. And for pure semiconductor, in case of pure semiconductor, number of electrons, number of charge carriers per unit volume, that is called charge carrier density, that is equal to number of electrons plus number of holes, and number of electrons equal to number of holes. Because one bond is broken means one electron. Suppose one electron become free means one vacancy, one hole will be created. So as temperature increases, equal number of holes and electron. So electron hole pair will be created. That is what we are taking here the equation. Ne is equal to NH. But as temperature increases, a less number of electrons become free, like out of 10 power 9 atoms, 1 electron becomes free. So very less number, so that the number of charge carriers are not enough to give the sufficient electricity to conduct the semiconductor. So that's why we will do some other thing. Like what we do is we go for doping, which results in two types of semiconductors, P-type and N-type semiconductor, that is called extrinsic semiconductor. Now, what is extrinsic semiconductor is after doping, means adding impurities. So doping nothing but what? Adding impurities. That is called, we will add different type of atoms so that the number of electrons or holes we will increase, so that number of charge carriers will increase. That causes the more electricity or more conduction of semiconductor. Now, what is the current in intrinsic semiconductor? So in case of intrinsic semiconductor, as I said, the current is due to electrons and holes. So the current equal to, what is the equation? NeAVD. Now electron current is Ne, number of electrons per unit volume, A, and VE. Same way, IH equal to NHEAVH, where V is drift speed. So that the total current will become, here E into A is common, NeVe plus NHVH. This is what the equation of current in a semiconductor, intrinsic semiconductor. But here Ne equal to NH. So that is what you need to understand. Now, what are the types of extrinsic semiconductor? As it said, when we add pentavalent atom, pentavalent just like phosphorus. So phosphorus will replace silicon, so that as phosphorus has 5 electrons, so 4 electrons will make bond with silicon and 1 electron becomes free. So it will donate. So 1 electron, that's why we call it as donor. So this electron will become free electron in the material. Now, when we add trivalent atom like aluminium, then aluminium replaces silicon, but aluminium is trivalent, so only 3 electrons will be there. So one vacancy will be created, that is called hole. So when you add pentavalent atom, 1 extra electron will become free, so more number of electron carriers will increase. When you add trivalent atom, more holes will increase, so that here more electrons, that is Ne greater than NH. When you add pentavalent, that will become N-type semiconductor, and more holes means NH greater than Ne, that is called P-type semiconductor. So these are the two types of semiconductors where the equation is NeNH equal to Ni square. So based on which they used to ask questions. Let's see a few examples based on this, like how they will ask the question. Now in an intrinsic semiconductor, the number of conduction electrons is, so electron number they have given 7 into 10 power 19 per meter cube. Find the total number of current carriers, electrons and holes in the same conductor of size. Now for a volume of 1 centimeter, so 1 into 10 power minus 2, 10 power minus 2, 1 millimeter means 10 power minus 3, that is total 10 power minus 7 meter cube, this much of volume. The number of electrons will become 7 into 10 power 19 into 10 power minus 7 equal to 7 into 10 power minus 12. But as it is pure intrinsic semiconductor, Ne equal to NH, so the total number will become Ne plus NH. So that way you can solve the questions. Now one more question. Pure silicon at 300 Kelvin has equal electron and hole concentration. So Ne equal to NH equal to 1.5 into 10 power 16 per meter cube. By some means, hole concentration increases to final hole concentration is 3 into 10 power 22. Now calculate Ne in the silicon. As Ne NH equal to Ni square. So this is the initial one, means this is initial one. Intrinsic semiconductor concentration. Now Ne NH equal to Ni square. Now NH is given, Ni is given. Then they are asking Ni is Ni square by NH. So that is what you need to calculate. So this way you can understand. So here it is like indirectly they are telling hole concentration increased means p-type extrinsic semiconductor. Now the next question is the number of conduction electrons in per meter cube in a semiconductor is, number of electrons they have given 6.5 into 10 power 19 per meter cube. Calculate the number of holes in a sample having dimensions. Now number of holes they are asking. See, as number of holes and number of electrons both must be same, Ne equal to NH. Then, but per particular volume they are asking, so number of electrons will become 6.5 into 10 power 19 into, what is the volume given? 1 centimeter, 1 centimeter, 2 millimeter. So 2 into 10 power minus 3. So this will give you the answer. Now, what will be the conductivity of pure silicon crystal at 300 Kelvin temperature? See, they are asking about conductivity. See here, the formula for conductivity is actual formula. See, NE mu E plus NHE mu H, where mu is mobility. But here Ne equal to NH equal to Ni, that is intrinsic semiconductor concentration, and mu E mu H are mobility of electron and holes. So both values they have given. Mu H is 1350 centimeter square means 10 power minus 4 per volt second, and mu E equal to 480 centimeter square means 10 power minus 4 per volt to second. So mu E mu H values given. E is charge of electron 1.6 into 10 power minus 19, and Ne NH, that is intrinsic hole concentration, that is they have given as Ni equal to 1.072 into 10 power 10 per centimeter cube they said. So per centimeter cube means divided by centimeter cube means 10 power minus 6 meter cube. So that it will become 1.072 into 10 power 16 per meter cube. So now we got all the values so that you can substitute in the given formula. Now, one last and final question. In p-type semiconductor, the majority and minority charge carriers are respectively. See, p-type semiconductor means, p-type means we will add trivalent. Trivalent means more number of holes, so that NH is greater than Ne. So the more number of charge carriers we call it as majority, and less number we call it as minority. So more holes, so majority charge carriers are holes and minority are electrons. So this way they can ask question based on the equation formula based, or they can ask theoretical based. So you can understand from whatever we have discussed. So just try to solve the numericals which I have given here, similar type of questions, so that you will get practice with those equations. And even in NCERT also they have given 5 questions. See, theoretical type of questions also they have given. So just try to understand all the questions so that you will get the better idea. So thank you all. We'll continue in the coming session with another question.